11.5 independent and dependent events, I can calculate the probability of independent and dependent events.
Yes or no?
Yes.
Enthusiastic voices, please.
Yes.
Okay. Compound events, 2 or more events would be compound. Independent, dependent events, they are basically opposite of one another, right?
Yes.
Independent events do not, everyone say do not, impact each other.
Impact each other.
Dependent events do, say do, impact each other.
Impact each other.
Make sense?
Yeah.
Okay. So independent events are, well, they're both pretty simple, I think, if you understand the formula. Independent events, if we are using an example of drawing a marble out of a bag, what is the probability? The formula is the probability of A times the probability of B gives you the entire probability of those compound events, right? So what is the probability, at least in letter A here, that I will draw a red marble?
3 out of 7.
3 out of 7, because there's 3 red marbles out of 7 marbles in the bag. So theoretically speaking, the first draw will be a red. If I put that marble back in the bag, would it have any impact on my second draw?
No.
Because I drew a red out, I put it back in the bag, it does not impact the second draw, does it? So then what's the probability I'll draw a blue one in my second draw? 4 sevens. And if I multiply those together, I get a total of 12 over 49. We didn't talk about this, but could I make a tree diagram to get that exact same answer?
Yes.
I could, right? So what's the probability of the first event? It would be a red, a red, a red, a blue, a blue, a blue, and a blue, and then we would do our tree diagram, right?
Yeah.
Okay, and we could have found that it was 12 out of 49. Because you would see red and then blue 12 times. And then I did letter B. I'm not going to talk about letter B, but basically we did 3 drawings. Multiply them together. Dependent events then. The formula was a little tricky for us. Everything stays the same. This is the probability of dependent events, just like the probability of independent events. See if I can get them both on the screen at the same time, and I can't. So the probability of independent events is A times B, right? The probability of dependent events is still A times B, but B is after A takes place, because they are going to impact each other. Event A has a major impact on event B, right? Okay, and in this situation is, again, we have our bag of marbles. Instead of putting the marble back in the bag after I draw it, I keep it. Will that impact the probability of the second draw then?
Yes.
So I drew a red and then a blue. What's the probability of drawing a red from that bag?
Yes.
And then what's the probability of drawing a blue?
4.
4 out of 6, because I never put the marble back, right?
Yeah.
Again, probability of independent and dependent events would be opposite one another. Independent events, no impact, basically theoretical probability. Dependent events, there is an impact, still theoretical probability, but you got to be very careful on that second or third or fourth draw, or second or third or fourth event. Questions?